This is a question on Faraday's law and AC generator, and the answer to this question is D. D is a statement that is not true. So if you look at statement B, it's a direct application of Faraday's law. When you increase the rotational speed, the coil actually cuts the field lines faster, and this means that there will be a greater induced EMF and induced current. For options A, C, and D, it is best answered if you recall this diagram from the notes. So we have to be able to draw this, sketch this induced voltage or induced current against time graph, and juxtapose it against the orientation of the coil at different junctures in time. So when the coil is horizontal, we are always going to get the maximum induced EMF, or induced current, and maximum induced EMF or induced current when the coil is horizontal. So this directly contradicts option D. That's why D is the statement that is not true, and that's the answer. When the coil is vertical, you can see that the portion of the coil AD, for example, the direction of force is towards the right. The direction of magnetic field is also towards the right. The force and magnetic field direction, it will be parallel whenever the coil is vertical. And when these two directions are parallel, there wouldn't be any generator effect. So you will not be generating any induced EMF or induced current. Hence, when coils are vertical, the induced EMF or induced current value at point 2 and point 4 is 0. So we have to be clear on how we can sketch this graph, and also identify the different positions of the coil. And lastly, if you notice, the direction of the induced current or induced EMF changes every half a cycle. So over here you get positive current or positive EMF, then after half a cycle you get current moving in the opposite direction. So that's why option C is a correct statement. The induced current in the external circuit is an alternating current that alternates direction every half a cycle.